Hi guys, actually this is not Shiyang. I'm Shiyang's little brother Shiyang. Today, I'm gonna talk something about HONO sources and its impacts on the ozone formation in China. This is our Earth, and this is my hometown China. Unfortunately, with the rapid industrialization, the emissions of NOx and volatile organic compound in China are increasing rapidly. This causes a sharp increase of ozone concentration in China. Some recent studies shows that nitrous acid, HONO, which can produce OH and NOx through daytime photolysis, can contribute greatly to the ozone formation. To figure out this process, first we must know where those HONO come from. At nighttime, the most important formation pathway of HONO could be the hydrolysis reaction of NO2 on humid ground surface or surface of aerosols. Here is the reaction equation. NO2 plus water form HONO and nitric acid. However, at daytime, there are serious proportional HONO sources. First, the homogeneous reactions of HONO. There are two reaction pathways of the homogeneous reaction. OH plus NO to form HONO. The second one is 1 mole of NO2 can react with 1 mole of water to form 2 moles of HONO. The second process is the heterogeneous reactions. In this process, NO2 can convert into HONO on organic surface or aerosol surface. This source can account for nearly 40% of known daytime HONO sources. HONO can also be emitted directly from the fossil fuel combustion, especially the traffic emission. Recent studies showed that the HONO emission from the ammonium oxidizing bacteria may account for up to 50% of total nitrogen emission from soil. Therefore, direct soil emissions can be an important HONO source in rural area or farmland regions. Also, some field measurements indicate that the conversion rate of NO2 to HONO in the air passing over sea surface is 3 times larger than the rate over land surface. So, HONO carried by sea wind can also be an important source in some coastal cities. However, besides the sources I mentioned above, there are still about 67% of unknown HONO sources here, which indicates that we still need to do further study to figure out those missing HONO sources. Okay, after the introduction of HONO sources, let's come to the ozone formation mechanism. First, just a review of what we have learned in our class. The NOx circle and HOX circle are the two dominant pathways for the tropospheric ozone production. Here, ozone production process is dominated by the oxidation of chemicals such as carbon monoxide and methane. As we mentioned before, the photolysis of HONO can provide a source of new OH and NO. So, it can propagate the NOx and HOX ozone formation circle and increase the ozone production. Essentially, how could HONO affect the ozone production largely depends on the ozone sensitivity condition. At NOx limited regime, ozone is sensitive to NOx and increases with the increasing amount of NO. In this case, NO produced from the HONO could be the dominant contributor to the ozone production. However, at the VOC limited regime, ozone is more sensitive to VOCs and increases with the increasing number of VOCs. since OH is the most important oxidant of the VOC's oxidation process. Increasing OH will propagate the VOC ozone formation cycle and enhance the ozone production. Alright, after my introduction, let's welcome my big brother Shiyang talk something about the case study in his final paper. Hooray!